Ever wondered what happens in that split second between you typing an address into your browser and a website magically appearing on your screen? It feels like magic, but it's actually a fascinating system of connections, data, and protocols working together at lightning speed. Today, we're going to demystify the internet and give you a complete, beginner-friendly explanation of how it all works. By the end of this video, you'll understand exactly how that cat video travels across the globe to your device. So, what is the internet? At its core, the internet is just a gigantic global network of connected computers. We're talking billions of devices from massive data centers to your laptop, your phone, and even your smart fridge. They're all linked together, allowing them to share information with each other. Think of it like a global postal system, but for digital data. To understand this system, we need to know about two key players: clients and servers. Your device, your computer, tablet, or phone is a client. When you want to watch a video or visit a website, your client sends out a request for information. That request goes to a server. A server is essentially a powerful computer that stores websites, videos, images, and all sorts of data. Its job is to listen for requests from clients and send the requested information back. So when you go to YouTube, your browser is the client asking a YouTube server to send it the web page and the video you want to watch. But how does your request know where to go? How does the server know where to send the data back? This is where IP addresses come in. Every single device connected to the internet has a unique identifier called an IP address, which stands for Internet Protocol Address. It's like a digital mailing address. It's a string of numbers, like 192.168.1.1, that tells other computers where to find it on the network. Without IP addresses, data would be completely lost. Now, you probably don't type a string of numbers to visit your favorite websites. You type something like youtube.com. That's because we use domain names, which are human-friendly labels for those numeric IP addresses. Remembering google.com is a lot easier than remembering 142.250, 191.78. The system that translates these easy-to-remember domain names into their corresponding IP addresses is called the DNS, or Domain Name System. You can think of the DNS as the Internet's phone book. When you type a domain name, your browser first checks with a DNS server to find the correct IP address, and only then can it send the request to the right server. Once your browser knows where to send the request, the information doesn't travel in one big chunk. Instead, every piece of online information, whether it's an email, a picture, or this video, is broken down into thousands of tiny pieces called data packets. Each packet is labeled with information about its origin, its destination, and its place in the larger file. Breaking data into packets makes the transfer more efficient and reliable. If one packet gets lost or corrupted along the way, only that small piece needs to be resent, not the entire file. These packets then begin their journey across the internet, guided by devices called routers. Routers are like the traffic cops of the internet. Their job is to direct packets across the vast network of networks, always trying to find the quickest and most efficient path. Your packet might travel through dozens of different routers on its way from the server to you. Each router examines the packet's destination address and forwards it to the next router on the best path, a process that happens millions of times per second all over the world. So, what are these paths made of? How does data physically travel across continents and oceans? The backbone of the internet is a massive network of fiber optic cables. These are thin strands of glass that transmit data as pulses of light, allowing information to travel at nearly the speed of light. These cables run under our oceans, connecting continents and across land, forming the superhighways of the internet. For more remote areas or for mobile connections, data can also travel wirelessly via satellites in space or cellular towers on the ground. This brings us to your internet service provider, or ISP. Companies like Comcast, Verizon, or AT&T are your gateway to this global network. Your ISP connects your home to the wider internet, managing your connection and routing your data to and from the global backbone. Without an ISP, your home network would be an isolated island. Inside your home, you have two key pieces of equipment, a modem and a router. The modem is the device that connects to your ISP's network, translating the signal from the fiber or cable line into a digital signal your devices can use. The router then takes that internet connection and creates a private local network in your home, allowing multiple devices like your laptop, phone, and smart TV to share the connection, usually through Wi-Fi. Now, let's talk about the language computers use to communicate. For the web, the primary language is HTTP, or Hypertext Transfer Protocol. It's a set of rules that browsers and servers follow to request and send information. You've probably also seen HTTPs. The S stands for secure. HTTPs adds a layer of encryption, scrambling the data as it travels. This ensures that if someone were to intercept your data packets, they wouldn't be able to read them. That SYU should always look for the padlock icon and HTTPs in the address bar when you're re-entering. Sensitive information like passwords or credit card numbers, when the packets finally arrive at your browser, it's time to assemble the website. A modern web page is typically made of three main types of files. HTML, or Hypertext Markup Language, provides the basic structure and content: the text, the headings, the images. CSS, or Cascading Style Sheets, is responsible for the presentation, the colors, the fonts, the layout. It's what makes the website look good. And JavaScript adds interactivity, things like animations, pop-up menus, and dynamic content that updates without you needing to reload the page. Your browser acts like a construction manager, reading these files and assembling them into the complete, interactive web page you see on your screen. To make this whole process faster, browsers use something called caching. When you visit a website, your browser saves certain parts of it, like logos, background images, and other files, on your computer's hard drive. The next time you visit that site, your browser can load those files directly from your local storage, the cache, instead of having to request them from the server all over again. This makes websites load much faster on return visits. Another tool for speed and efficiency is a CDN, or Content Delivery Network. A CDN is a network of servers distributed all around the world that store copies of a website's content. When you request a video from a large platform like YouTube, you're not necessarily connecting to a single server in California. Instead, you reconnected to a CDN server that's geographically closest to you, maybe in your own city or country. This dramatically reduces the physical distance the data has to travel, which means faster loading times and smoother streaming for everyone, no matter where they are. While we're on the topic of websites, let's touch on cookies. No, not the delicious kind. HTTP cookies are small pieces of data that a website stores on your browser. They're used to remember information about you. For example, a cookie can remember that you're logged into your account, so you don't have to enter your password every time you visit. They can also store your preferences, like your language choice or the items in your shopping cart. Let's also quickly define cloud computing. Instead of running software or storing files on your personal computer, cloud computing lets you do it on powerful remote servers accessed via the internet. When you use Google Docs, stream a movie on Netflix, or store photos in iCloud, you're using the cloud. It allows you to access your data and applications from any device, anywhere in the world. Of course, with all this data flying around, security is a huge concern. We already mentioned HTTPS encryption, which scrambles data during transfer. Another crucial security tool is a firewall. A firewall acts as a digital security guard for a network. It can be a piece of hardware or software that monitors incoming and outgoing traffic and decides whether to allow or block specific data packets based on a set of security rules. This helps to block unauthorized access and prevent harmful activity. A quick word on streaming, since that's how you're watching this video. Instead of downloading the entire video file before you can watch it, streaming sends the video to you in a continuous flow of small chunks. Your video player starts playing the first few chunks while the next ones are still being downloaded. Your player also constantly monitors your internet speed and can automatically adjust the video quality from 1080p down to 480p, for example, to ensure the video plays smoothly without constant buffering. And how do we find anything in this sea of information? That's the job of search engines like Google or DuckDuckGo. They use automated programs called crawlers or spiders to constantly browse the web, moving from link to link and discovering billions of pages. They then index this information, creating a massive searchable database of the web's content. When you type in a search query, the search engine's algorithm sifts through its index in a fraction of a second to find and rank the most relevant pages for you. Finally, a common point of confusion. The Internet versus the World Wide Web. They're not the same thing. The Internet is the physical infrastructure, the cables, routers, and servers that form the global network. The World Wide Web, or just the web, is the system of interconnected documents and content that you access using browsers. The web runs asterisk on asterisk the Internet. So, the Internet is the hardware network, and the web is the information that flows across it. And that's it. From client requests and IP addresses to routers, packets, and protocols, that's the journey your data takes every single day. It's a complex but incredibly elegant system that has connected our world in ways we never thought possible. I hope this breakdown made the Internet a little less mysterious. If you found this explanation helpful, please give this video a thumbs up and follow the Fact Flip for more deep dives into the technology that shapes our world. Thanks for watching, and see you in the next one.